So now for lesson 9.5, we are still dealing with the concept of area under the curve, but instead of our lower boundary being the x-axis, we're going to be bound by another curve instead of the x-axis. And so in a nutshell, what we're going to be doing for this section is simply finding the area under the top curve, which is going to give us all of this, and then subtract out the area under the bottom curve, which would be this area, and if we subtract out this, then that's going to leave us with the area between the two. And so we're basically going to be doing the area of this one, of this curve, minus the area under this curve to get what's in between. So here we go. One thing you have to recognize on this, and this is where either a calculator would come in handy or just a sketch of your own graph, is first of all, you have to identify which one is on top and which one is on bottom. So if I were to graph these two graphs, the square root of x gives me this arc that you see here. This is my square root of x. This arc is created by the x squared, and so I need to do the square root of x minus the x squared in order to get what's in between them. So the other thing you have to identify is where those two graphs intersect. So the left boundary is this point of intersection, the right boundary is this point of intersection, and so that's what's going to create the definite integral from the left boundary to the right boundary, are those 2 points of intersection. That can be done on a calculator as well. If you graph the two graphs and then go under calc and choose intersect, your calculator can do those points of intersection for you. One thing I caution you on, and I'm going to warn you again at the end of the video, and I'm glad you're watching this, is don't get too heavily reliant on your calculator. There are times where you're going to be having to do these problems either without a calculator, or the problems are written in such a way where you have to show the work. And so really important that you know how to show the work for these, not just use the calculator. But anyway, to find the points of intersection by hand and not the calculator, I would simply set the two graphs equal to each other and solve for x. And so if we solve for x, I'm going to get two solutions. One of them would be 0, one of them would be 1. So there we go. We found our left boundary and our right boundary with those 2 points of intersection. So we are going to integrate from 0 to 1. We're doing the top curve minus the bottom curve to get the area between them. And so I'm just going to start out with the top curve. So the square root of x, we're going to integrate this. We're then going to evaluate it from 0 to 1. So that's what you're seeing on the first part. So here's the integral. And if we evaluate that from 0 to 1, we're going to get the area under that curve is 2/3. And so 2/3 represents this entire area that you see here of 2/3. For the x squared, so here's the x squared, we're going to integrate this and evaluate it from 0 to 1. And so here's the integral of x squared. And if we evaluate this from 0 to 1, we get an area under that curve of 1/3. And so that's this white area that you see here is 1/3. So we're simply going to take the overall area of 2/3, subtract out this 1/3, and that's going to leave us with the area between them, which is 1/3. All right, here we go on with number 2. Again, I'm given two curves, two functions. So we got the parabola that you see here. We have the line that you see here, and we are finding the area between them. And again, this will really help if you sketch graphs on this. So if we were to sketch the parabola that you see here, as well as the line for 2x plus 1, you're going to get these two graphs that you see here. That's going to help with a couple things. It's going to help identify which graph is on top and which graph is on bottom. So you can see that the line right here is above the curve from 1 to 4. And so now if I want the area between them, that helps me to see that the line is on top, the parabola is on bottom. So that's the order I'm going to do this in. It also helps me identify their points of intersection. I can also now see that the entire graph is above the x-axis, so I know that it's all going to be positive. I don't have to worry about subtracting out negative areas under the curve. So a good sketch will really pay off. Again, you can do this in a calculator, but you really need to know how to do this by hand as well. So if I were to set the two equations equal to each other and solve for x, I can see that my x values are 1 and 4. And so that's going to give me my left and right boundaries. So we're integrating from 1 to 4. And again, we're going to do the top area. So I'm finding the area of from 1 to 4, everything below this line. Then we're going to subtract out this area right here. I want you to keep something in mind. If you look at the area created by this line, so right here, right here, right here, and right here, you have a trapezoid. And so one option would be, instead of doing the integral of the line from 1 to 4, you could just find the area of that trapezoid, which is 1/2 the height, which is 3, times base 1 plus base 2. And so that's another option, and some people take that route. So that's the area of a trapezoid. But we can also do it with integrals, of course. And so here's the best layout that you're going to see for that. So I'm doing the area under the line minus the area under the parabola, and that's going to give me the area between them. So there are two ways to do this, and you can pick either route. But if you look at this rule right here, this might really help you in some cases. The idea is I can subtract the functions first before I do the definite integral. So one option that you have, if you look at this one right here, if I'm going to go from 1 to 4, I can subtract first. I can do 2x plus 1 minus x squared minus 3x plus 5 and come out with one singular function, and then evaluate that function's integral from 1 to 4. And so that's an option. You can do that first. And that's what you're seeing on this. You can do them separately like you saw in the very first example, but this works too. If I am to subtract these two functions first, this is what I would come up with. And now all I have to do is integrate this one function and evaluate it from 1 to 4. So if we were to integrate this function right here, this is what you would come up with. We can now evaluate that one function from 1 to 4 to get our area. So now I can plug in the 4, I can plug in the 1. I'm going to subtract those two answers. Really important that you show the work on this in case you get the answer wrong. But this is what you would come out with for that area. You get the same answer if you did them separately. You can start by just finding the area under the line first and evaluate, do the integral on this, evaluate it from 1 to 4. You can then do this one completely separately, find its integral, evaluate it from 1 to 4, and then subtract at the end. Or you can subtract at the beginning like we did here, and then just do an integration process once instead of twice. So either way, we're going to get the same answer. And again, you guys saw in the last video, there are ways that we can do this on the calculator. But again, please be mindful that there's going to be plenty of times where you either don't have a calculator handy because you're doing a portion of a test that's a non-calculator portion of the test, or it's written in such a way that you have to show the work, and so it's important that you know how to show the work for this. If you were going to do this in the calculator, all you would have to do, the easiest way to do this is go to your y equals and just type this in. This is what we are graphing. We're going to graph this function minus this function. So that's what you're seeing right here. I'm just going to subtract the two functions and just use parentheses. If you type it in exactly like this in y equals and then hit graph, you'll get the graphs that you see on the right. You can identify their points of intersection by going under Calc and choosing Intersect. And you can get the 2 points of intersection. And then if you go under Calc and choose option 7 and do the integral with this is your left or lower bound and this is your upper bound, you can get the area that way. So if you want to give that a try in your calculator, give it a try. You can do it with this one as well. All I did for this one was I just graphed this function. And so I did the subtraction by hand to come up with this one function, and then I just graphed this function and did the integral from 1 to 4 and that still gives me 4.5. So you can do it that way as well. But again, I really want you to know how to show the work for this, so please do that. Use the calculator as simply a way of checking your answer at this point. Do not do them all by calculator, or you're going to end up losing points on a test if you go that route.